Soils store the vast majority of the world's terrestrial carbon. Each year, soils emit almost 10 times as much carbon as humans emit on an annual basis. The only difference is, those emissions are balanced off by equivalent amounts of uptake.
As the climate warms, soil activity, organismic activity at the microbial level will increase. This means that as these organisms, these microbes, start to have more activity, they will breathe more, they'll respire more.
Accelerating carbon losses into the atmosphere, speeding the process up by 1.5 gigatons of carbon each year. This can accelerate the rate of climate change by up to 17%, which is like having another industrialized country the size of the United States on the planet.
So we know that a warming climate will cause soils to release or respire more carbon. However, we don't know whether or not nutrient enrichment will offset this effect.
Global nutrient enrichment is the increased availability of things like nitrogen, phosphorus, and potassium that can stimulate plant growth all over the world. We expect that increasing nutrient enrichment might lead to increased carbon uptake as those plants grow faster and faster. And that might potentially offset all of the warming-induced carbon losses that we discovered in previous work. For a global study like this, it's impossible to get a proper perspective until we have that network of ecologists all across the globe. That's where the Nutrient Enrichment Network comes in. It's an incredibly unique project that brings together experts from all across the world, which gives us that full global perspective.
The Nutrient Network has a global community of points where scientists have set up experimental plots with soil and actually tested what happens when you enrich the soil with nitrogen, phosphorus, potassium, or a combination of those nutrients. So the key here is comparing the plot response that has had nutrient enrichment to the plot response that has not had nutrient enrichment. In other words, we want to look at the differences between a plot that's had a lot of nutrients on it versus just a normal soil plot. Because we have a global range with these points, we're able to estimate what would happen at every other location on the planet in response to global nutrient enrichment. So one of the main results that we found is that soils do often increase their carbon storage potential when given a combination of nutrient enrichment, meaning not just nitrogen, phosphorus, or potassium alone, but a combination of all three. One of the most fascinating results of this study was that even though some of the plots that we studied had increased amounts of carbon, when we applied our models to other places around the world, we actually saw that upper latitudes, high latitude soils could experience a decrease in soil carbon content.
This is incredibly concerning because these are the locations where the vast majority of the world's soil carbon is currently stored. We know that warming is stimulating the loss of carbon, releasing an extra 1.5 gigatons of carbon every year that accelerates climate change by up to 17%. Our maps now reveal that nutrient enrichment is very unlikely to offset these effects, and it could actually accelerate those changes. This means we need massive reductions in fossil fuel emissions and also fertilizers, because these are the two biggest contributors to global nutrient enrichment and the responses that we're seeing under global change.
So this study helps us increase our overall understanding of the terrestrial carbon balance given anthropogenic nutrient enrichment.
This global scale information can be used to benchmark Earth system model projections of soil carbon sensitivity to nutrient enrichment. But even more importantly, it can actually be used to guide those models to describe which ecosystems are most vulnerable to change and how much carbon we're going to lose into the atmosphere over the rest of the century.
So understanding how these soil carbon dynamics will play out only increases or improves our ability to ward against the negative effects of climate change.